Derivative as a rate of change, mean value theorem and Rules theorem. Derivative as a rate of change. Rate of change, we already know that's a slope, like y2 minus y1 over x2 minus x1. This is rate of change. Or in calculus, f of a, f of b minus f of a, and b minus a. We call this a secant slope. So rate of change is a secant slope and a derivative. This is a derivative, and we're gonna deal with mean value and Rolle's theorem. Consider the value of differentiable function f of x in the table below to answer the question that follow. Plot the points and connect them on the grid below. Differentiable function means like we can take a derivative of this, like it's differentiable, or you can say we are going to find the limits for the derivative from the left and limit for the derivative from the right, and if they have the same left and right, it's differentiable. But we already know they are telling us it's differentiable. So let's graph them, plot the points. I have 0 and 2, so this is 0 and 1. I'm sorry, I'm reading it wrong. 0 is x and 1 is right there, so 0 and 1. Then I have 2 and 5, that's 2, and this is 5. Then 4 and 8, this is 4, and we're gonna go 8. 6 and 10, that's 6, and I'm gonna go all the way. Where is 6? So this is 6, 6, 6, 6, and it's 10. This is 6, 10, 8 and 11. This is 8, and I got 11, 10 and 10, 10 and 10 right there. 12 and 8. This is 12, and I'm gonna go all the way to 8. 14 and 5, so 14 and 5, and 16 and 1. Here we go. So I'm gonna draw. It looks like a parabola, and it's differentiable. We know that. Okay, that's a parabola. And I'm gonna make this like a 0 slope so it doesn't go like cusp. In calculus, the derivative has many interpretations. One of the most important interpretation is that the derivative represents the rate of change of a function. So these are the vocabulary words that you have to vocabulary, and you can check those vocabulary words on your memorizing page. What are the vocabulary words we use for the derivative? It's gonna go rate of change. Write it down somewhere, please. Rate of change, tangent. I'm just reviewing this again. Rate of change, tangent, instantaneous rate of change, instantaneous rate of change. These are all the vocabulary words for derivative. Okay, so when speaking of rate of change, there are two rates of change that can be found that are associated with the function: average rate of change and instantaneous rate of change. Instantaneous rate of change of a derivative. But what is average rate of change? Average rate of change means a secant slope. When you see the word average rate of change, that's a secant slope. So average rate of change on the interval and instantaneous rate of change of f of x at a point. So let's do that. We can say, for example, our average rate of change means a secant slope. I already said that, secant slope. And this one is tangent, like tangent and derivative, tangent slope. So this is what I got. Now I can say on the interval a, b, for example, the definition is on the interval a and b, closed intervals, the average rate of change is defined to be f of b minus f of a over b minus a. That's a secant slope. We already know that, but average word, remember that. Average rate of change means secant slope. What else? And also, if you guys remember, For the secant slope, there is also vocabulary words for it. For example, average rate of change. That's one word, rate of change, that you guys learned today. And also approximate, when it says approximate f prime or estimate f prime, these are all secant slope. So tangent slope of f(x) at a point, this says at a value x equal a, the instantaneous rate of change is defined. Rate of change is defined to be f prime a, like a derivative. Now let's try this. Find the average rate of change of f(x) on the interval 2 and 12. So this is 2 and that's a 12. In this they want me to find average rate of change. And like I said, average rate of change means what? Secant slope. So I'm technically doing, this is intervals. Interval means x. So this is a and that's a b. So I have to look for their f of a and I have to look for f of b. So I can use, for the average rate of change, I can use f of b minus f of a over b minus a. So I already know my b minus a, which is 12 minus 2, but what is f of 2? So this is 2, and what is the y value? That's 5. That's f of 2. I'm sorry, I have to get the f of 12 first. So this is 12 and the y value is 8. So that's 8. That's 8. And this one is 5. So this is what I got. 8 subtract 5 is gonna give me 5, 6, 7, 8, 3. And 12 subtract 2 is gonna give me 10. So my slope is 3 over 10. Is the instantaneous rate of change of f at x equal 4 greater than the rate of change at x equals 6? Justify. So this instantaneous rate of change means f prime 4, and the rate of change at 6 means also f prime 6. So let's try a tangent slope at f prime 4 first. So I'm gonna draw with a different color. I'm gonna do f prime 4 first. So let's try f prime 4. This is 4, and I'm gonna draw a tangent line here. So if I pick 2 points on this, like this one and that one on the tangent line, so I'm rising 2 and then running 1. So actually the answer for that is 2 approximately if I do it. And then when I draw on 6 with a different color, 6 is right here, that's a 6. And when I draw a 6 tangent slope, then I'm rising and I'm running. I pick these 2 points. So it's just 1. So f prime 6 is 1. So yes, f prime 4 is greater than f prime 6. So I'm going to say the instantaneous rate of change, the instantaneous rate of change at x equal 4, which means f prime 4 is greater than f prime 6 rate of change, because the slope of the tangent, at x equal 4 has the greater slope. There. Okay, next one is my Rules theorem. What is Rule theorem? Okay, so Rule theorem said if, for every theorem we have conditions. So for this one we also have condition. If f of x is continuous, that's the first condition, continuous on AB, closed intervals. And the second condition is indifferentiable, like you can divide it, you can take a derivative of it, differentiable on AB, and another, the third condition, and f of a is equal f of b. When I plug in these intervals in the original equation, then it's supposed to be equal the same y values. Then there must exist at least one value x equals c on AB such that f prime c is equal 0. Now remember a few things in the Rolle's theorem, and I'm going to show you guys what do I mean by this. It has to be continuous, it has to be differentiable, two conditions. Third one is f of a has to be equal f of b, third condition. If all the three conditions are there, then it means there must be at least one value x equals c on AB such that then you're going to take a derivative of the function and you're going to make it equal 0 so you can get the c. Every time for any theorem, when the conditions are good and the theorems are applicable, then you have to find the c for each one of them. And for that c, every theorem has a different formula. For this one, it's f prime c. And if you guys remember, for intermediate value theorem was when you make the f of x equal k. That was intermediate value theorem. This is f prime c, it's a Rolle theorem, and you have three conditions. Remember the wording, this is very important. At least wording is very important, such that wording is very important. If you see these things, then that's a theorem we are talking about. Now, consider the function f of x presented on the previous page. Does Rolle theorem apply on the following interval? Explain why or why not. 214 is the intervals. F of x, where is f of x on? Right there. This is f of x function, and they are talking about if 2 to 14, the intervals that I have, is the Rolle theorem applicable. I can see from 2 to 14, I can see it's continuous. So the first thing, yeah, it's continuous, and it is differentiable because the question is already telling me this whole thing is a differentiable right there. Okay, the first two conditions are good. The third condition is f of a equal f of b? Like, for example, is f of 2 is equal f of 14? So we're going to check that. 2 is right there and the y value is 5. 14 is right there and the y value is a 5. So yes, for both of them it's 5, equal 5. So yes, Rolle theorem is applicable in this first interval. So let's write it. F of x is continuous and differentiable on 214, interval 2 and 14, and f of 2 is equal f of 14, and both of them are equal 5. So yes, that condition is there. Then Rolle's theorem is applicable. There. And it's not a function, so otherwise I would apply this third one. They didn't ask for the c. Okay, interval 2 and 10. So let's try interval 2 and 10, from 2 to 10. So this is 2 and all the way to 10. I know it's differentiable from 2 to 10, and it's also continuous, but f of a is not equal f of b because f of 2 is 5 and f of 10 is 10. So no, it's not applicable because f of a and f of b are not the same. So f of x is continuous and differentiable. I can just write both of them like this, and differentiable on 2 and 10, like closed intervals, but f of 2 is not equal f of 10. So Rolle's theorem is not applicable. There. Next one, For each of the function below, determine whether Rolle theorem is applicable or not, then apply theorem to find the value of C guaranteed to exist. If the three conditions are there, if we meet the three conditions, then we're going to find the C. How do you find the C? We're going to apply f prime C equals 0. That's how we find C. So let's try that. I know -3 to 0, this is my polynomial function. And we're going to see if we every time polynomial is continuous, so it is continuous on -3 and 0. So I'm gonna say and for example, one more thing, if you guys remember in the past one, if the function is differentiable, then it has to be, must be, you can say must be continuous. But if it's continuous, then sometimes differentiable or sometimes not. But if it's continuous, then sometimes differentiable and sometimes it's not. So that's how it goes. So since it's differentiable, I can take a derivative of this. It's differentiable, it's good, then it means it has to be continuous. So I'm going to say the first condition right there, g of x is continuous and differentiable on -3, 0. Done. Now the other one is f of a and f of b. So is f -3, what is that? And I have to find f of 0. Then we can say f of a and b are equal to each other. So I'll plug in -3 here. If I plug in -3 here, I'm gonna get 0. If I plug in 0 here, I'm gonna get 0. So yes, f of -3 is equal f of 0, and both of them are equal 0. So the Rolle's theorem is applicable. If it's applicable, we're gonna do g, since that's the g function, I'm gonna say g prime c is equal 0. For the x, I just put in c because they are asking for c. I changed the x to c. So let's take a derivative of that. So I'm gonna go 18x minus 4x cubed equals 0. Now I can do the common factor first. So what is my common factor here? I can 2 is a common factor, 2x. Or I can say instead of x, we can change this to c to make them feel better. So that's a 2c, it's a common factor. So that's 9 minus 2c squared equals 0. So make this equal 0 like we usually do. Make this equal 0. This one is going to give me c equals 0. That's 1. And then I'm going to go for this one. To -2c squared equal -9. You divide 2 both sides, so it's gonna give me c squared equal +9/2. If it's +9/2, we're gonna go and square root this portion and that, so it's gonna give me c equal +3/√2, because 9 is a perfect square, so it's 3, but 2 is not, so I'm going to keep that in the square root. So I got positive and negative square root. Now we have 0, positive, -3 square root. I have to check all 3 of those c's if they are falling between -3 and 0, the intervals. So I know 0 is not between -3 and 0. Actually, 0 is my end interval, like it's starting -3 and 0. So I'm not going to say c is between -3, 0. It's not. So this one is not working. Let's try square root 3/√2. Positive -3 to 0. Positive is not going to work between -3 and 0 because it starts -3, then -2, -1, and then 0. But positive is not going to work. There is no positive there. So positive not working, but negative is going to work. So my c is equal -3/√2. So that's my answer for the c. Let's try this question. Sine 2x, x plus 2 on the interval. First, we have to figure it out if it is continuous on -4, -1. So if you guys have really confusion about -4 and -1, you guys can just draw a sign like number line -1. So it's between here. So I know that for the differentiability in the continuity and thing, I can see it's a differentiable, but I don't know. We can take a draw. Let's figure out the continuity first. So if one of the condition is not meeting, like if it's not continuous, it's not differentiable, f of a, f of b is not the same, so Rolle theorem doesn't apply. So x plus 2, since it's a denominator, when I make this equal 0, I'm going to get x equal -2. -2 is between -4 and -1 right there, which means that's a vertical asymptote and it's not continuous. So Rolle theorem is not applicable. So I'm going to say g of x is undefined at x equal -2, or you can say has a vertical asymptote at x equal -2, which is on -4, -1 closed intervals. G of x is not continuous. You guys can use the vertical asymptote reasoning too. I just said undefined. It's not continuous, and Rolle's theorem is not applicable. Theorem is not applicable. Okay, so let's try. Rolle's theorem guarantee that a function is continuous on the closed interval, differentiable on the open interval, f of b equals 0, then there is a guarantee to exist a value of c where the instantaneous rate of change is equal to 0. Instantaneous rate of change means f prime c is equal to 0, because instantaneous means a derivative. Okay, let's try the mean value theorem. The mean value theorem is similar. In fact, Rolle theorem is a specific case of what is known in calculus as a mean value theorem, but let's try mean value theorem, and Rolle theorem is done. A mean value theorem, I'm going to call this mean value theorem. Again, the conditions: if f of x is continuous, all of them is continuous and differentiable, again the same thing like a Rolle's theorem, and differentiable on AB, then there must exist a value x equals c on AB such that f prime c, like instantaneous rate of change, or you can say tangent slope, is equal secant slope. There you go. So again, you have to remember the condition. The first condition, it has to be continuous, differentiable, and if that's the case, if it's continuous and it is differentiable, then we're gonna apply this formula to get the c. And in this formula, tangent slope, instantaneous rate of change, derivative equal secant slope. So let's try. Consider the function hx 3 minus 5 4x. The graph hx is pictured below. Does the MVT apply on the interval -1 and 5? On -1 and 5. Explain why or why not. MVT means I have to look for the continuity and differentiability. So -1 to 5. This is -1 and that's a 5. So I'm talking about from here to here, and you can tell the graph is going only on 1, like not -1. I don't have any graph here, so it is not even continuous there. So I'm gonna say the MVT does not apply here, does not apply on -1 and 5, because explain, right? Because hx is not continuous. At x equal 0. So it's not continuous at x equals 0. Like, do you see the 0 from all the way up there? It's not continuous and it's undefined. Does the MVT apply on the interval 1 and 5. So let's try 1 and 5, and I'm going to use a different color. This is 1 and that's a 5. So 1 and 5 from here to all the way up here. So yes, it is continuous, it is differentiable, and MVT is applicable. Okay, so in this one I'm gonna say each x is continuous and differentiable. We can take a derivative, we can make a tangent slopes everywhere, and differentiable on 1, 5. So MVT is applicable. Okay, let's try this one. Graphically, what does MVT guarantee for the function on the interval 1, 5? Draw this graph to the left. So when it's applicable, then actually we are looking for C, right? And the C side, f prime C is equal f of b minus f of a over b minus a, like a secant slope is equal tangent slope. So let's try and draw this. So at x between 1 and 5, right? So I'm gonna draw, let's draw a tangent slope. That's a tangent line. Here we go, tangent slope. And then I can also draw a secant slope by connecting these two dots right there and right there. So look, tangent and secant are parallel. They're gonna go parallel forever, which means if they are parallel, these two slopes are supposed to be exactly the same, right? This is f prime c. This one is a secant, like f of b minus f of a or b minus a, because this line is going through 2 points and this one is only going through 1. One is tangent and going through 2 points is a secant. So you can tell they are parallel. So don't you think they're supposed to be the same slopes? So I'm going to say MVT guarantees a value of C between x equal 1 and x equal 5, where the tangent slope, h prime x, since this is h function, I mean right here, h prime x is the same as the secant line slope or secant slope, which is h1 minus h5 over 1 minus 5. Like I picked 1 and 5. Then next question, they said apply the MVT to find the values of C guarantee of h of x on the interval 1, 5. Since h of x is given right there, so I can apply that, and we already know it's continuous, and we already know on 1 and 5 it's differentiable. So how do I do that? I'm going to take a derivative of that h prime x first. This is going to give me, how do I say that? It's going to give me, let's rewrite the question first. Okay, let me rewrite it because of that. I don't want to use a quotient rule. If I can avoid this quotient rule, I'll do it. So I'm going to go hx equal 3 minus 5 over x. I'm going to rewrite that. It's going to give me hx equal 3 minus 5x and negative 1. So now I'm going to take a derivative of this. That's going to give me, this is 0, but negative and negative is going to give me positive 5x and negative 2. We already know, since we are looking for the C, so I'm going to change everything to C. H prime C equal 5 over C squared. That's my derivative. Now let's figure it out, f of b minus f of a. So I'm going to go, let's make it, how do I say, 5c squared h prime is equal f of b minus f of a. I can say that's a and b. So I'm going to go f of 5 minus f of 1, or you can do the other way around as long as the bottom is going to stay the same way, 5 minus 1. So what is f5? This is 5 and that's 2. So 5 over c square equal 2 minus f of 1, that's 1, and it's negative 2. F5. Yeah. I'm sorry, that's H5 and H1. What is H5? This is 5 and that's 2, okay? Minus, and another one is negative 2 over 4. So this one is going to give me 4 over 4, which is 1. Okay, now if it's 1, then we're going to do, let's get the c by itself. So technically I got 5 over c square equal 1. Now explain why you cannot apply the mean value theorem for x 2/3 minus 2 on the interval -1 and 1. The first condition for mean value theorem is if the function is continuous and then differentiable. I don't know if it's continuous or not. I can't tell, but if I can find out if it's differentiable or not. If it's differentiable, then it has to be continuous. You know that, right? If it's differentiable, then it has to be continuous. So let's try found differentiability. So if I'm taking a derivative f prime x and differentiable between -1 and 1, f prime x, I'm taking a derivative of that, 2/3 jump to the front, and then I have x, 2/3 subtract 1 is going to give me -1/3, and 2 derivative is 0. So this is what I got. Now I'm going to fix it. It's going to 2 on the top, 3 in the bottom, -1/3, it's a negative exponent, it's going to go in the bottom too, like this. Now if -1 and 1, so if I plug in here, since I need to know between -1 and 1 it's differentiable or not, or continuous, so I'm gonna say this is not differentiable, because when I plug in 0 here, -1 and 1 has a 0 in the middle. If I plug in 0 here, it's gonna be undefined. So I'm gonna say, since f prime x is undefined, so it's not it's undefined at x equals 0, which is on -1 1. The f of x is not differentiable, so it is not differentiable. So mean value theorem is not applicable, and if you guys can check, if I graph this, and you will see it's not going to be differentiable. It is continuous, but it's not going to be differentiable. So let's try this is the I can show you the tab. This is the graph, x 2/3 minus 2, and it is not differentiable at 0 because it has a cusp. So it's not differentiable. It is continuous, but it's not differentiable. Okay, because of the cusp. So let's go back. Not applicable. MUT is not applicable for f of x on -1 1. Okay, find the equation of tangent line to the graph of f of x, 2x plus sine x plus 1 on the interval 0 and pi. Interval means all the x values at the point which is guaranteed by a mean value theorem. Tangent is derivative, equation is y minus y1 equal mx minus x1. So the last thing they are asking me is y minus y1 equal mx minus x1. I need to have x1, y1 and a slope. Now, where this mean value theorem fit in here, since you guys can tell, I have to have a x, so I can plug in it in the original to get the y. I can get the derivative, the slope from this, So the mean value theorem is actually this: f prime c is equal f of b minus f of a over b minus a. Secant and tangent are the same. So 0 and pi is my a and b. I don't have a x value. Both of them are intervals like x values, but not technically I need a x value. This c, I need this c, which is my x1. I can plug it in here. I can plug in that c in the original. I can get the y1 and I can get the slope. The slope is gonna work here. If I plug in the 0 and pi here, this is the slope is gonna give me. Why I'm not saying, since the tangent and secant is the same, why I can do this one, because when I take a derivative of this, I still don't have a c, so I can plug it in and I can get the f prime. But I know that the tangent and the secant is exactly the same, so whatever I get from this, it's going to be exactly the same over here. So let's try finding out the mean value theorem, all this. So it will give me c, it will also give me a slope. So let's take a derivative of that, the f prime x, it's going to be 2, the derivative of 2x, the derivative of sine x is cosine x, and the derivative of 1 is 0, equal, what is f of b? F of b means pi, and minus f of 0 is a, and pi minus 0. So I have to find f pi, f0. So let's try, this is my scratch pad, and I'm going to plug in f pi first. Plug in f pi in here in the original, that's 2 pi plus sine pi plus 1. So it's going to give me 2 pi. What is sine pi? Sine pi is on this side and sine is 0. So that's 0 and that's 1. So actually my answer is 2 pi plus 1. Then plug in f of 0. When I plug in 0, 2 times 0 is 0. Sine 0 is, what is sine 0? Sine 0 is, I think, let's try, 2 0 plus sine 0 plus 1. I think this is 0 and sine 0 is also 0, like a y value, and that's plus 1. So that's just 1. So let's plug in everything, and I'm going to change this x to c because you know we need a c. Cosine c, so that c is my x. You already know c is always x. So cosine c, f pi is 2 pi plus 1 minus 1, that one for f of 0, and I got pi minus 0. So they cancel out, pi cancel out, I'm left with 2. So I got 2 plus cosine c equal to, and it's going to subtract 2 both sides. I need a c, that x value. So cosine c equals 0. When I divide cosine both sides, it's going to go inverse. So I got a cosine 0. What is cosine 0 on the unit circle? Cosine 0 on the unit circle is pi over 2. So that's my x value. That's what I got for x. So I can write that x minus pi over 2 over here. And my slope was 2. This is the slope we got. I already told you this, and this is exactly the same because I don't have a c here right now, so which I already figured it out now. But when you plug in c, pi over 2 in here, you will get the, this is a derivative. When you plug in the pi over 2 here, you will get exactly 2. So 2 is equal to. So this is 2, my slope. And then y1, I have to get that y1 now. How do I get y1? Plug in this pi over 2 in the original, which is 2 pi over 2 plus sine pi over 2 plus 1. So 2 to cancel out, I am left with pi plus sine pi. What is sine pi? Sine pi is 1. Sine pi over 2 is 1, and that 1. So I got pi plus 2. So my y value is y minus parentheses pi plus 2. We will distribute that negative we have to, but I mean technically we don't. So this is my equation, tangent equation, and guaranteed by mean value theorem. Why they are doing this to get the mean value theorem? Because they are giving me intervals, but they're not specifically telling me what x value should I have. So this mean value theorem is giving me that x. If you guys have any questions, please comment below.